Imagine a room full of people. Some are whispering while others are shouting. If you're trying to even out the noise, what would you do? Ask the shouters to tone it down or tell the whisperers to speak up. This, in essence, is the problem of imbalanced data sets in machine learning. Scene script. Picture a data set with two classes. One of these classes is significantly larger than the other. This imbalance can lead to biased predictions, as the machine learning model is more exposed to one class than the other. Two primary techniques exist to tackle this problem: oversampling and undersampling. Oversampling is like asking the whisperers to speak up. It involves duplicating or generating new samples from the minority class so that it matches the size of the majority class. Picture an animation where the smaller group starts to grow, gradually matching the size of the larger group. It's like magic, isn't it? On the other hand, undersampling is akin to telling the shouters to quieten down. This technique randomly removes samples from the majority class until it's on par with the minority class. Imagine an animation where the larger group begins to shrink, eventually matching the size of the smaller group. It's a balancing act, isn't it? Each technique has its own pros and cons. Oversampling can sometimes lead to overfitting, as it may replicate outliers. On the other hand, undersampling might result in loss of information, as it discards potentially useful data. The choice between these techniques depends on the specific dataset and problem at hand. It's not a one-size-fits-all solution. It's about understanding your data, the problem you're trying to solve, and choosing the technique that best serves your purpose. Remember, the goal is not just to balance the classes, but to improve the performance of the machine learning model. So don't be afraid to experiment, innovate, and learn. After all, machine learning is a journey, not a destination. So go ahead, dive into the world of oversampling and undersampling, and explore the magic of balancing classes in machine learning.